Hi guys, today we're going to look at shifting functions. So you can see that that's our topic for today. And we're also going to talk about this thing called Hicks-Voy that's going to help us remember the horizontal transformations and vertical transformations, and we'll get there in just a few minutes. You'll understand what Hicks-Voy means once I actually explain it. We're just going to first consider the absolute value function. F of x equals absolute value of x. It's helpful to have a calculator so that you can type these in, but if you don't have one, that's okay. You can just follow along with me and then graph it on your own paper. Absolute value of x looks like this, where we go up 1 over 1, up 1 over 1, up 1 over 1, starting at the origin. And I want to tell you quickly that this first function, f of x, is called the parent function. And then each of the functions below are like the children functions because they come from the original function. So here again, we start at the origin. If you have color pencils or highlighters, I suggest doing these in different colors because we are going to have 3 different graphs plotted on one single grid. So starting at the origin, I'm going to go up 1 over 1, up 1 over 1, so on and so forth. And then we're going to connect them. We're going to do the same thing on the other side, except this time instead of going towards the right, we're going to go towards the left. And connect them. Then we're going to label this with f of x equals absolute value of x, because that's what we just plotted. So that was part A. Now part B says graph the function f of x minus 3 inside parentheses plus 2. So we have to actually change forms here. Let's say we're going to call this g of x. And it starts with f of x minus 3 inside parentheses. That means that I have absolute value bars, because remember the parent function was absolute value of x. So we have x minus 3 inside the bars with a plus 2 on the outside. Now again, if you have a graphing calculator, it will be helpful. If not, that's okay. Just graph with me as I plot. I've already typed this in my calculator, so I'm just going to give us the coordinates as we plot them. So we're going to start with -5, +10. 1, 2, 3, 4, 5, 1, 2, 3. Okay, just kidding. That won't fit. Okay, so let me just scroll on my table on the calculator to see where we can actually start fitting on our graph. Alright, so it looks like -1, +6. -1, 1, 2, 3, 4, 5, 6, all the way up at the top of your graph. And again, if you have different colors, it's helpful to use them. I'm choosing to do this second one in purple. Then we have 0, 5, 1, 4, 2, 3. Then we have 3, 2. And now we're going to start going back upwards. 4, 3, 5, 4, and 6, 5. That's as far as we can go. Now this time we're going to choose to label this as g of x equals absolute value of x minus 3, close the absolute value, plus 2. Now let's talk about what's happening in this graph. We went from the blue to the red here. We started, let's say at the origin down here. The vertex, the turning point, is at the origin. So if I take this vertex at 0, 0 and move it to the new vertex over here at 3, 2, it looks like we're shifting to the right 1, 2, 3, and then we're going up 2. So let's make ourselves a note of that here. For part B, we went right 3 and up 2. Now if we make an observation about the direction in which we're moving and the numbers in our function, you can see that we took -3 inside the bars. Now typically minus means negative, and if we're talking about x's, negative is in the leftwards direction. So this means that if we have a negative, we actually don't follow the direction if it's inside your bars or inside your parentheses or inside whatever it happens to be. We do the opposite. However, if it's on the outside like this +2, we did shift in the direction that typically means plus. +2 means up 2. Now we're going to graph one more to see if we can make the same observations according to a new child function, if you will. So we have graph the function f of x plus 1 inside parentheses minus 4 outside the parentheses. So first let's call this h of x equals, we have our absolute value bars with an x and a plus 1 inside them. Close it up and we have a minus 4 on the outside. So now I'm going to choose to graph this in a different color. Again, typing it in the calculator is helpful. If you don't have your calculator with you, that's okay. Just follow along with me. So this time we can start at -6, +1. So all the way to the left and then up 1. Then we have -5, 0, -4, -1, -3, -2, -2, -4. Just kidding, I meant -2, -3. Sorry. -2, -3. Then we have -1, -4. And now we're going to start to go back upwards. 0, -3. 1, -2. 2, -1. 3, 0. And keep going up 1 over 1 just like that, in that fashion, until you hit the edge of your graph. And again, we're going to label with h of x equals absolute value of x plus 1, close it, minus 4. Alright, so let's talk about what we see happening here. Going from our original parent function, the red, or not red, from blue towards our new function h of x in red. So you can see here that this time, if we look at the turning point or the vertex at 0, 0, we are shifting not towards the right this time, but towards the left. And it looks like we went left 1, down 4. So let's write ourselves a note. For part C, we went left 1, down 4. So let's interpret this again. I have a plus 1 on the inside. That took us to the left 1. Plus 1 typically means move towards the right, towards the positives, but in this case, it was the opposite again. So if it's inside, it looks like we're doing the opposite direction. However, on the outside, we have a minus 4, and that did in fact take us down 4. So on the outside, it follows the direction. On the inside, it's opposite. So this next question says, how would the graph of f of x equals absolute value of x be shifted in order to produce the graph of f of x minus 6 inside the parentheses, minus 8? Now we could certainly transform this to, I don't know, L of x, a new function, and say that this is absolute value of x minus 6 minus 8, and we could graph it and we could see what happens, but you can interpret what's happening to a graph just by looking at what's happening to the function. So we have a minus 6 on the inside. Remember, on the inside, it typically was taking us left or right, and it took us in the opposite direction. So this minus 6 on the inside is actually going to shift us right 6. Then the minus 8 on the outside follows the direction, so we go down 6. I'm going to give you a quick practice problem on the left-hand side here. You don't have to jot it down, but think about what your answer will be, and I'll put it up here in just a minute. I want you to describe what shift will be happening if we have the function f of x plus 2 and then plus 3 on the outside. Again, I'll give you a second to think about it, and then I'll write the answer up here. Hopefully you said left 2 and then up 3. And the reason for this is because the 3 on the outside means up or down, and it's positive, so we go with the direction. The 2 on the inside means left and right, but we go opposite of the typical direction. And we're going to actually summarize this right here, starting with Hicks and Voy. Hicks stands for horizontal, inside parentheses. It doesn't have to be parentheses, it could be absolute value bars, it could be before you square something, whatever it happens to be. And then it affects the x's. So x's are affected. Horizontal always occurs inside parentheses, and it affects the x's. The next one, voy, means vertical, and it goes outside the parentheses, and the y's are affected. So a vertical translation or a shift occurs when k is added or subtracted. I just use symbols here, added or subtracted, outside. Notice that I put this all in caps, outside, because that's where we go either up or down when it's outside the function. So we have the shift goes upwards when k is positive. K is just a number, by the way. So this would be something like f of x in parentheses, close them up, and then write plus k. So if we have a plus k on the outside, that means we're moving upwards. We shift down when k is negative. So again, f of x, close parentheses, but this time minus k on the outside. Outside, vertical, y's, meaning up and down. That's where this voy comes in. Vertical, outside, y's are changed or affected. So we shift up or down. Then if we talk about horizontal, it occurs when k is plus or minus, or meaning subtracted, inside. So the graph shifts right when k is negative. So this looks something like f of x minus k, close parentheses. The graph shifts left when k is positive. And again, this looks something like f of x plus k, close parentheses. This is where that Hicks part comes in. Hicks, horizontal, left and right, being inside the parentheses. And you may just want to write yourself a note here with the horizontal, is that the signs do not match the direction of the shift. And this is what I was talking about earlier. This positive 2 up here off to the side that I had you try, this positive 2 inside parentheses took us in the opposite direction of what typically positive means. So the sign for horizontal translations do not match. Again, do not, I did not write a not in there, oh my goodness, do not match the direction of the shift. All right, let's flip the page and get some practice real quick. So you're going to start by trying some of these transformations on your own after we do, say, part A and B together. A and B are just two typical transformations you might see. We have this parent function, y equals f of x, and then we're doing stuff to it. Adding inside, adding outside, subtracting inside, subtracting outside. So we have to think about that Hicks and voy before we decide are we moving up, down, or left, right. And then we'll decide which direction based on the sign. So here I have a plus 5 on the outside. Outside means to use voy. Remember that O means outside. So if it's voy, that means the y's are being changed, which means we're going in the vertical up-down direction. So if I'm going up or down and it's positive on the outside, this means that I choose up. My sign matches the direction if it's outside. Now the next one, I see a plus 5 on the inside. So here, if it's inside, that means use Hicks. So the x's are affected, meaning we're moving in the horizontal left-right direction. And this is where the sign does not match the direction, so you really have to think about it for a second. Plus 5 typically means move towards the right, but we have to do the opposite. So this means that we have left 5. If you want an explanation for this, it's something similar to the fact of when we have a quadratic equation like x squared, I don't know. Let me give you the factors, we'll say. X minus 4 parentheses and x plus 2 parentheses equals 0. You know how there's that step where you have to t-chart and you set each factor equal to 0? and then you solve, add 4, you get x equals 4. This is where that sign, -4, is being switched. So it's the same process here. We have to essentially think about setting it equal to 0 and solving, but we just kind of do it all in our head so that we don't have to show this work each time. So again, inside parentheses, the sign does not match the direction. Outside parentheses, the sign matches the direction. So now you're going to try part C and D. Then go ahead and move on to E, F, G, and H. And for these, you're going to have 2 shifts. So one will be up, down, and the other one will be left, right. Start with left, right, and then go to up, down. Pause the video while you do this. Then when you're finished or you need to check in, hit play. You'll see that my answers are going to be up there. Again, pause it while you work on this independently. Okay, so you can see my answers here for C through H. You can see that I was writing myself notes each question that I did. I said either Hicks or Voy. And then when I got to the 2 shifts questions, E through H, I said, okay, I've got a Hicks one and I've got a Voy one, a Hicks one, a Voy one, and I took each one piece by piece. If you need more time to check your answers, just pause the video. Otherwise, follow along with me for example 2. Example 2, we're looking at graphically shifting functions again, and also evaluating. So it says that we have this function f of x as shown below, and I want you to take either your highlighter or a colored pencil, box in f of x, and then actually shade it in on your graph. I know it's a little hard to see, especially that horizontal piece. And then I want you to make 4 really nice points for me. One at this top left, one at the bottom left, bottom right, and then top-ish right. So 4 really nice points on that graph. Then the next part says a second function, g, is defined by g of x equals f of x minus 3 inside parentheses, and then plus 1. So what I want to do first is actually part B. Then we'll go back to part A afterwards, because we'll use the graph for that. So it says identify how the graph of f has been transformed to produce the graph of g, meaning what's happening? What's that minus 3 on the inside telling you? What's the plus 1 on the outside? So inside again means Hicks. Inside I is in Hicks. So then we affect the x's, meaning that we move left and right. It's a minus on the inside, which means we move in the opposite direction. So hopefully your brain's telling you that we're moving right 3. Then in the outside, we see this plus 1. So that means that we're using Voy, O, outside, Voy. So then outside means up and down, and we follow the sign. Positive plus means up 1. So that's exactly what we're going to do. We're going to take each point, like this really nice one in the top left, and we're going to move it to the right 3 and up 1, plot a new point. So again, take each point, move it to the right 3, up 1, plot it. Use a different color if you have it. Then take the next point, right here, move it to the right 3, up 1, plot it. That was me just using this point where you see my red laser. Right 3, up 1, plot. Now moving on to this bottom right point, right 3, up 1, plot. And then we have one more point to do, this top-ish right one, to the right 3, up 1, plot. Alright, so I'm just using a ruler here, not a ruler, a straight edge tool, kind of, a line. Apparently that's not going to work out so well. Let me try again. Connect this point. What? I don't know what the deal is with this. Okay, try to connect them as best you can in a straight manner. It's kind of hard for me on here on the iPad, but again, do the best that you can. And then we're going to label this with g of x. So I want to show you how to answer part A. There's two ways you can do it. One of them is graphically and algebraically mixed together, and then the other way is just simply graphically, and I think that this is the easier of the two options, so I'm only going to focus on showing you this option here. You can always go back and look at the notes key if you'd like to see the other option that is a mixture of algebraic and graphic. So with this, it says evaluate. Well, it doesn't say evaluate. Let's write that ourselves. Evaluate g of 0. So g of 0 means to go where x is 0 because we're plugging in a value, an input, and we're getting an output. So I'm going to go over to 0 and then up to where my g of x graph is. And I can see that it's right here at approximately 2. Again, that's why it's kind of nice to use a straight edge if you can to connect your points, because then you definitely see that it's at 2. And that's it. Simple as that. Just use your brand new graph. Use new graph. That's the reason I wanted to graph first and then do the evaluating second. Go ahead and flip it over. We're going to look at some domain and range questions, I believe. Okay, so this next one says a function has a domain of -3 less than or equal to x less than or equal to 10. Domain, remember, means x values. And a range of y is less than or equal to 22. Range is y's. So it says what are the domain and the range of the function f of x plus 7, close parentheses, plus 10. So first thing I want you to do is look at this function and tell me what's happening. Left, right, up, down. I'll give you a minute to do that independently. Write it on your paper, please. Okay, so I said left 7, up 10. This positive 7 inside, we have to do the opposite, so move towards the left. Positive 10 on the outside, stick with the direction of the sign and move up 10. Now, if we are going to the left 6, you don't have to draw this, but just, have your eyes here for a minute with me. If I'm moving towards the left 6, 1, 2, 3, blah, 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 I'm going and subtracting from the x's. So this means to -7 from x. If I'm going upwards 10, up, 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 that means that we are adding, so plus 10 to the y's. So all we have to do is actually what we just said. Subtract 7 from the x's and add 10 to the y's. So we start with -3 less than or equal to x less than or equal to 10. And where we said that we're going to subtract 7 from the x's. You have to do it from both of them because they are both x values. -3 minus 7 is -10. Less than or equal to x, less than or equal to 10 take away 7 is +3. So here's the first part to our answer. The next part comes from doing the range. Y less than or equal to 22. Now there's only one range value here, the 22, and we said that we are adding 10s to the y values. So we're just adding 10 one time here. If there was another value on the left side of this y right here, we'd also add 10 to that, but there's not, so we're just sticking with the 1. So we have range, y is less than or equal to 32. Simple as that. You just have to add or subtract based on what's happening to the function. In a lot of these problems, you have to identify what happened first before you can take any further steps, which is what I'm going to ask that you do in part A. It says, given the quadratic function, describe the shift. So tell me, what's that -4 mean to do, and what's the -5 mean to do? So the -4 on the inside, that's Hicks. That means we're changing the x's left and right, and we do the opposite, so that's right 4. On the outside, that's Voy. -5 means actually shift it down 5. Now you might have been wondering, what do you do with this squared, the little 2 there? You do nothing with it. The parent function, as you can see, was y equals x squared. So all we did was take that squared and do stuff inside and outside of it to create a new function. So the squared just was part of the parent function, and you just leave it alone. You just keep it there. The next part, we're going to stick with part B, but then we're going to ignore the rest of the question because you won't be tested on it. It says that y equals x squared has a turning point at the origin. It's kind of like that absolute value one where it went like a V shape and the turning point was the vertex at the bottom. Well, x squared has a very similar look, except that it's rounded, it's a parabola, and that turning point is at 0, 0. But now we just said that we are shifting to the right 4 and down 5. So if we go to the right 4 from 0, 0, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5, that means that our new turning point is in a different location. Right 4 means add 4, down 5 means subtract 5. We do that to x values and then the y values. 0 plus 4 is 4. 0 minus 5 is negative 5. Boom, done. Now let me give you another example. Say that the original turning point was at 2, 3. Now I'm asking you, what's the new one based on this description? Right 4, down 5. So again, that means add 4, subtract 5. So the new turning point is at 6, negative 2. Let me give you another example for you to try on your own. So say the original is at negative 2, positive 1. What are the coordinates of the new turning point? Hopefully you said 2, negative 4, because we're adding 4 to the x values, subtracting 5 from the y values. Like I said, we're going to skip the rest of this problem here. Flip it over to your next page, please. Okay, so I want you to take a look at example 5. It says that we have the function f of x shown below. Maybe you want to take a color and highlight it, make it stand out to you. Find some really nice points on that graph, like this bottom left one, the vertex at the very top, and this bottom right one. Then figure out how to graph g of x, which is equal to f of x minus 2. Determine what's happening and then actually do it on your paper. You should be thinking either I'm moving left 2, right 2, up 2, down 2. Figure it out. If you need to look back at your notes, that's fine. I'm going to do this independently on my paper, as should you on yours. If you're getting stuck, check in with me. I'm going to keep the video running and you should do the same unless you feel as though you're just going to look at mine. Don't do that. If you think you're going to, pause the video and then you can see it afterwards. Alright, so you should have shifted those 3 points to the right 2. The minus 2 on the inside tells us to change the x's, and inside tells us to do the opposite, so move towards the right because of that negative 2. Now we're going to evaluate, and it said I wrote ourselves a note that says look at the new graph. So if I look at my new graph and I'm finding g of negative 3, remember that's an x value, so go to the left 3 from the origin, 1, 2, 3, and go to the new graph. So not the red one, don't stop right there at the red one or the old one that was already plotted, but go down to your new graph. So we're going down 1, 2, 3, 4, 5, 6. So g of -3 is -6. Okay, now try the next one. G of 0. Remember, that's an x value. Go over 0 and then up to your graph. How far upwards are you counting to get to your brand new graph? Over 0, up 1, 2, 3. So g of 0 is equal to 3. Then the last one, go ahead and try that on your own. I'll write the answer up here in just a minute. You should have found -3 here. G of 4 is equal to -3. If you'd like to try the practice, I will put the answers up here on the board or on your screen in just a minute. Otherwise, you may move on to your homework and tick it out. Try the homework first before you try the tick it out. That way you can get some practice. Hang tight though, because I want to tell you what homework questions to focus on, because there are a couple things, remember, that we skipped. So just hang tight and I'll tell you homework questions in just a minute. Okay, so you can see that I have the answers for the practice here. If you need to pause the video so that you can actually have a chance to do it on your own, please do so and then check back in. And then I want you to take a look at your homework so we can circle problems together. So take a look over at your homework and I'm going to show you what I have up here on the screen in just a minute. Okay, so for your homework, let's actually fill in this first part together. If we have a vertical or horizontal translation, we may want to think of Hicks voy. So if it's on the outside, that of course means voy. If it's on the inside, that means Hicks. Remember, I'm coming up with this because O means outside, O is in the word voy. I means inside, I is in the word Hicks. So if it's a plus K on the outside, that means we are shifting up K. See if you can fill out the rest and then check in for your answers with me. Okay, so for the next one, you should have had down K, then left K, and right K. So we're going to circle these problems together. We're going to circle number 2. You are also going to circle number 3. And number 4. Flip it over and we'll see what ones to circle on the back. Circle number 5, number 7, and we will do 8A and B. Okay, so you can see that the solutions are at the bottom. They are not for you to just copy, but they are for you to actually work through first and then do on your own to check it afterwards. Okay, so if you need to go back and rewind, please do so. Otherwise, you have the questions to work on for your homework, and then you also have a ticket out to complete.